Hello everyone, welcome back to my channel, Infosec Lab. Today we're going to talk about AI security, a new learning path from TryHackMe. This path focuses on real AI threats like prompt injection, data poisoning, and vulnerabilities in large language model. You start with the fundamentals, how AI models work, how they process data, and how attackers exploit them. Then you move into hands-on labs where you actually practice these attacks by yourself. You interact with the AI systems, simulate attacks, and learn how to defend against them. The exact skills that are becoming critical in today's security landscape. Let's get started. AI ML security threat. Introduction. The world is changing. Industries are coming to terms with the reality of how they will be affected by artificial intelligence, or AI, and cybersecurity is no different. It should come as no surprise that AI is at the heart of many discussions in the cybersecurity industry. A lot of ongoing research is being done to answer the questions so many have at this point. This room aims to answer these questions. What is AI or machine learning? How can it be used in our industry, which is cybersecurity? How will it affect my role, and how AI is being leveraged by attackers? This intro room aims to ease you into the world of AI so you can live with a better understanding of how the technology works and its implications for the industry and the world as a whole. The learning objectives: understand AI, machine learning, and their impact on the cybersecurity industry, understand deep learning and neural networks, and how they have made the applications of AI, as we see it today, possible. We also understand how adversaries use AI to enhance existing attacks and take advantage of model vulnerabilities. And last, we're going to understand the key role AI will play in defending against AI. The building blocks of AI. We must empower our cybersecurity workforce to combat AI security threats. Knowledge is power, so we're beginning by arming you with the foundational knowledge of AI and ML. So let's start by discussing how we define artificial intelligence. AI refers to a machine or computer system that is able to carry out tasks that would otherwise require human reasoning, comprehension, problem solving, and creativity. It's a term that, truthfully, doesn't have just one simple definition due to the sheer scope of its applications in today's society and its potential applications in the futures. Still, we can use this definition to begin to understand what it is and where it started. This term and field dates back in the 1950s, when research began on the pursuit of having machines perform tasks by simulating human intelligence. However, this was still a niche term that was not widely known. Machine learning. The next significant advancement of the development of AI came with the emergence of ML. Machine learning is a subfield of AI that refers to a computer's ability to learn from data without being given instructions, and is compatible to how the human brain learns. Over time, with more data and time, these algorithms will get better with accuracies and decisions. ML follows a structured life cycle to ensure the reliable development and deployment of models. This process begins with defining the problem, such as determining whether an email is a spam. Next, data is collected, cleaned, and prepared through feature engineering, ensuring meaningful patterns are extracted while avoiding overfitting. When a model's familiarity with the training data causes a failure to make generalizations on unseen or raw data. The model is then trained using a selected algorithm, followed by evaluation and tuning to optimize performance. Once defined, the model is deployed into a production environment for real-world use, such as classifying emails in real time. However, the life cycle doesn't end there. Ongoing monitoring ensures the model maintains accuracies over time, triggering retraining when needed. Since models require continuous improvement, the machine learning lifecycle remains an iterative process. Machine learning algorithms. Machine learning algorithms are mathematical methods used to learn patterns from data, while machine learning models are the trained outputs derived from these algorithms. These algorithms consist of three key components: a decision process, which makes predictions or classifications based on the input data, an error function, which evaluates performance and provides feedback, and a model optimization process, which fine-tunes the algorithms to minimize errors and improve accuracy. This process continues until the model reaches a satisfactory performance level. So when it comes to machine learning algorithms, we have three key components: the decision process, an error function, and model optimizations. Machine learning algorithms fall into four main categories: supervised, unsupervised, semi-supervised, and reinforcement learning. Supervised learning relies on the labeled data to train models for classifications or regression tasks, such as predicting house prices or identifying spam emails. Unsupervised learning, on the other hand, works with unlabeled data to discover hidden patterns. often using clustering, association, or dimensionality reduction techniques. Semi-supervised learning combines elements of both, using a small portion of labeled data to guide the learning process. Finally, reinforcement learning mimics human learning by rewarding correct decisions and penalizing mistakes, allowing an agent to refine its actions over time to achieve the best outcome. Neural network and deep learning. If you recall, the main objective of AI is to enable computers to behave like humans. One method that allows us to do this is through the use of neural networks. If you cast your mind back to high school biology, you may remember being taught how the human brain works. The human brain processes information using interconnected neurons, a type of cell responsible for transmitting communications between the body and the brain, which communicate with each other using synapses. Synapses allow the brain to send electrical or chemical signals from neurons to neurons. In other words, there are connections. This network of neurons learns by adjusting the strengths of these connections when we experience something new based on the pattern we encounter. It's this behavior that is replicated in a neural network. The diagram below represents a neural network. Like the human brain processes sensory input, the input layer receives raw data, and the number of nodes depending on data type. Each node represents a neuron. A connection between them acts as synapses. The hidden layers process and refine the input, bringing the network closer to a prediction. Each connection has a weight, determining its importance. For example, in email classification, the body text might have more weight than the subject line. The output layer then produces the final prediction. Consider a neural network tasked with recognizing a number from an image. Each hidden layer extracts different features. Early layers detect edges and curves, while the deeper layers combine these patterns to form a complete number. For example, lines might suggest a 1 or 7, while curves increase the likelihood of a 3, 8, or 0. The output layer, with 10 nodes, selects the most likely number based on the highest prediction value. This self-learning process mimics human brains, and when a network has more than 3 layers, it is classified as a DL algorithm, hence the term deep learning. Deep learning and machine learning can get confused sometimes, but we cannot understand the key differences between what we've covered. Like machine learning, deep learning is concerned with receiving data as input and producing some kind of prediction or classifications as output. Deep learning can take in labeled datasets, but the key difference is that deep learning doesn't need the data to be labeled. A deep learning algorithm can take unlabeled, unstructured raw data and determine its key features, which separate it from other categories. The important advantage here over the ML is that the data doesn't need labeling. This means deep learning doesn't require human interactions and, in that way, self-learning. It makes sense that deep learning is possible through the leveraging of neural networks. Because no human intervention is needed, large datasets can be processed and can, therefore, be thought of as scalable ML. The idea of neural networks have been around for decades and decades. So how come true potential of deep learning has only exploded over the last decade or so? This is largely due to the mass digitizations of information in recent years. Suddenly, masses of information was available to learning algorithms, and so, with deep learning, started a new era of AI in which we will unlock more potential and capabilities. So let's answer the questions. What category of machine learning combines both labeled and unlabeled data? Semi-supervised learning. What is the first layer of a neural network that handles incoming data, raw data? It's the input layer, which learning method does not require human labeled data and can extract features from raw, unstructured input. It's deep learning. What are the weighted connections between nodes in a neural network meant to simulate the human brain? Synapses. LLM. Large language models are deep learning-based AI models that can process and generate text by predicting the next word in the sequence. For example, consider this code. Ever have that feeling where you're not sure if you're awake or this code is missing the final word? This code will be fed into the LLM and it will be tasked with predicting what the final word is likely to be. When you create a chatbot, this is what's happening in the background. Predictions are being run quickly on what would likely be next in response of an AI. But how? LLMs are the first trained in the pre-trained phases, where they process vast amounts of text. GPT-3 alone was trained on data that would take a human 2,600 years to read non-stops. More advanced models, like GPT-4, require even greater datasets, made possible by deep learning. Instead of relying on labeled data, LLMs use billions of data of parameters that function like puzzle pieces, enabling them to understand and generate human-like language when accessed together. These parameters are fine-tuned automatically as the model processes text, adjusting based on prediction accuracy to improve response quality. They begin by generating a word at random to finish the text. Something like egg, for example. The guess is compared with what the correct final word actually was, and the parameters fine-tuned to make it more likely to predict what, until the model can accurately predict the correct word to the end of the sentence, and less likely to choose the incorrect words using an algorithm called backpropagation. So basically, what it does is to make several guesses, and based on those guesses, it will evaluate the output. So for example, like, or dreaming 65% compatible, asleep 15% compatible, hallucinating 8%. So the AI model, the large language model, will evaluate the output and pick out the one that best fits the sentence. Now, imagine this process happening trillions of times, repeating this process over and over again until it can not only predict the end of the training data, but also raw unseen data. The sheer scope of what is being discussed here is only possible due to the advancements in hardware, like GPUs, enabling masses of parallel operations and processes of large datasets, as well as the advancement of neural networks. Specifically, it's a type of network called transformer neural networks. Introduced in Google's 2017 paper, Attention is All You Need, transformer neural networks revolutionized LLMs by enabling parallel text processing instead of sequential word-by-word analysis. This breakthrough allowed the models to assign attention to keywords, improving contextual understanding. By encoding words into numerical values and calculating attention scores, transformers enhance accuracies, helping models correctly interpret ambiguous references, like distinguish whether it in the sentence referred to the bank or the loan. The bank approved the loan because it was financially stable. After the pre-training, humans come back into play, performing a step called RLHF, reinforcement learning from human feedback. This is when predictions are reviewed and any that would be considered unhelpful by a user or have issues are flagged and the parameters are adjusted accordingly. Once trained and reinforced, the LLM can be used whether as a translator, chatbot, etc. A query is fed into it, and using its trained model, it predicts what's next will be a response, and so on until the user has a complete response. LLMs power generative AI products like the ChatGPT and LLMA, which create original text-based content in response to users' prompts. Generative AIs as a whole extends beyond text, enabling the creation of images, music, and more. The recent AI boom is the result of years of research and innovation, not an overnight development. We've now explored key concepts and trace of AI's evolutions. Let's quickly recap how they connect. So now we have the AI, and we have the machine learning, which is a subset of AI. We also have deep learning, which is similar to machine learning, and within the deep learning we have generative AIs and LLMs. Artificial intelligence is overarching field, encompassing all systems that mimic human intelligence. Machine learning is a subfield of AI that enables systems to learn patterns from data without explicit programming. Deep learning is then a specialized branch of machine learning, which uses neural networks to process vast amounts of data in complex ways without the need for human interactions, making it effectively scalable machine learning. Large language models like GPT are advanced deep learning models built on neural networks, specifically transformer, designed to understand and generate human-like text. As was said, knowledge is power, and with these last few tasks, you have started your journey in the pursuit of that knowledge, and now have better understanding of the technologies that give AI its power. So now, let's take a look at how all this is affecting our industry. But before that, we have to answer these questions. What type of AI model enabled major advancement in ChatGPT and similar tools? Large language model. What is the first training stage where an LLM processes massive amount of data. Pre-training. What type of neural network is introduced by Google in 2017? Transformer. Okay, so let's talk about AI security threats. In this task, we'll focus on how advancement of AI technology discussed in previous tasks are being leveraged by adversaries, taking a look at a world of AI security threats. We will discuss AI security threats across two categories: vulnerability in AI models, new threats introduced by the inclusion of AI technology in business operations, and existing attacks that can now be enhanced by leveraging AI. The implications of AI in cybersecurity. Tackling a broad topic like AI security threats can be overwhelming, so any guidance is always appreciated. That guidance comes in the form of the Atlas MITRE attack framework. Let's take a look at it. The MITRE Atlas adversary threat landscape for artificial intelligence systems is a knowledge base of adversarial tactics and techniques targeting machine learning systems. Model on the attack framework, it documents real-world and research-backed attacks across the AI attack lifecycle, from initial access and model theft to inference manipulations and data poisoning. Each entry is grounded in observed incidents or proof of concepts research. Security teams use Atlas to identify AI-specific attack surfaces, select defensive controls, and communicate AI risk in a structured vocabulary. It complements the OWASP LLM Top 10 by providing a technique-level depth rather than vulnerability category summaries. Vulnerabilities in AI models. Prompt injection. Prompts are used to instruct the model on how to perform. For example, an RPG chatbot may have the prompt: "You are a fantasy role-playing bot. You control the direction of story text and be as creative as you can to create a story based on users' actions. Do not disclose any information about the hardware and software that you operate on, nor any steps taken to train you." Prompt injection occurs when the original instructions provided to the model are overwritten, often for malicious purposes such as disclosing more information about it or generating harmful content. Data poisoning. This is when attacker manipulates the training data or corpus used to train an AI model so it generated output as incorrect and biased. Let's consider our example discussed in the earlier task where we are training an AI model to recognize whether an email is spam or not. An attacker could perform a data poisoning attack to manipulate the training data being used to train this AI model so that it fails to recognize spam emails accurately, allowing spam emails they are trying to send to bypass AI filters. Model theft. Model theft occurs when an attacker gains unauthorized access to AI model. From here, attacker could potentially steal the intellectual property that lies within and even use it for malicious purposes. This attack is possible by querying the API of the ML model they want to steal. They would then use the output to train a clone model that mimics the behavior of the original. Privacy leakage. A privacy leakage vulnerability refers to the possibility of an AI model inadvertently revealing sensitive information about the data it was trained on, even if the data was supposed to be kept confidential. Consider an example of an AI model that has been trained on private medical data such as patient details and medical conditions. These vulnerabilities refer to the potential of an AI model to leak information to attacker or users. Model drift. Model drift refers to the potential for the model's performance to drift over time due to changes in the data or environment surrounding it. You may recall the discussions of the need to retrain model over time in early tasks. This is due to model drift, which is why monitoring an AI model once it has been deployed and is being used is so important. For example, this can occur when a model trained on historical data starts to perform poorly when new data is being processed. Enhanced attacks. Malware. With the explosions of generative AI, all kinds of content cannot be generated with an instant with just a few taps of the keyboards. This kind of power has been leveraged by all sorts of industry, such as the customer service industry, using it to give users access to a chatbot that can help resolve some common issues without the need to involve their human employees, meaning they can be saved into deal with the more complex user queries. Another industry that can greatly leverage this technology is software development. Now, with the power of generative AI, developers can generate code instantly while being incredibly useful. This also means that attackers can generate malware instantly simplifying the task and making it easier for them to attach using this method. Deepfakes. A key cornerstone of security is authentication, asking, are you who you say you are? We authenticate in many different ways in our day-to-day. Lives at work. Of course, there is an obvious example of password authentication, which is used to get access to the system. But let's consider another example. Imagine a secretary receiving a voice message or even a video call from their superior, asking them to forward the confidential information they hold on a customer to that customer. In the pre-AI world, the secretary wouldn't have to think twice about that request. It would seem like a standard request, and they are in a position to authenticate that is. In fact, their superior as they are familiar with the sound and the look. The recent AI advancement in generative AI have led to an explosion of rapid progress in the deepfake field. This means that if trained on enough data, an AI can now generate a person's likeness, whether that is their voice or their image, to a stunning degree of accuracy, fooling even the technically savvy. Imagine now that the communication received by the secretary was not, in fact, from the superior but a deepfake, and the customer email belonged to an attacker waiting to receive confidential customer information. It's easy to see how this advancement in deepfake technology poses a threat to the security industry. Examples of how this is being used include using the technology to defect a video interview, sometimes leading to fraudulent job offers being made. Phishing. Phishing is one of the most common initial access methods attackers use. Sending emails, posing to be the one thing when there lies malicious content within, attempting to prey on the user who receives it. Because of how common a method it is, companies have worked tirelessly to educate their workforce on things to look out when receiving emails, like suspicious links, and due to the fact of a lot of time these emails are written, having to write masses of emails, or English is not being their first language, broken language in email contents. Over the years, this training has had positive impact, and more phishing emails have been spotted. However, with generative AI, attackers can now generate detailed, fluent, context-based emails that replicate an email that is certain to user might receive, with little effort and regardless of their writing abilities. With this enhancement to phishing attacks, phishing emails have suddenly become a lot harder to spot, using solely our instinct. Of course, models like GPT, for example, have built-in mechanics to stop users from asking for malicious content to be generated, like a phishing email or malware. But using some of the model vulnerabilities discussed above, attackers are sometimes able to bypass this by engineering the prompts. So let's answer the question: what frameworks have developed by the MITRE to guide the understanding of AI-specific cyber threat? Atlas. What type of attack involves cloning an AI model by interacting with its API? There's going to be model theft. What generative AI technique can replicate a person's voice or appearance with high realism? Deepfake. What common social engineering attack has become harder to detect due to AI-generated fluent and convincing messages? Phishing. AI. So we have talked about AI security threats. Now let's discuss defensive AI. There are many ways in which we can harness this technology in cybersecurity to make our lives easier and, most importantly, help us fight against AI security threats. A very useful resource that helps shows us just how much this is the case. This is the case is about IBM's cost of data breach report, which they do manually. The findings from the latest report shows us that companies have adopted and embraced AI save on average $2.2 million in expenses due to data breach. This figure is even more impressive when you know the average cost of data breach in these latest figures was $4.88 million. That's a whopping saving. Other statistics from this report also tells us that the use of AI cuts down the time it takes to identify and contain a breach by 108 days. All these findings points to one thing: the best thing we can do for security is embrace and adopt AI. So let's consider some way AI can help us in this industry. Our ability to analyze. If you think about the tasks we do in cybersecurity every day, many of them involve some kind of analysis. We check in data points and look for patterns, and within those patterns are anomalies. Consider, for example, intrusion detection, where we analyze network traffic patterns to identify unusual activity that may indicate a cyber attack. Now, cast your mind back when we discuss LM. This is precisely the sort of task that LM thrives on handling. It is trained on data to recognize correlations between data points and make predictions based on those correlations, meaning this technology can be harnessed to help us in cases like the intrusion detection mentioned and many more. It can analyze input data, like the network traffic, and find anomalies for us, so we don't have to, and it can do so at dizzying speeds. Now, the figures from the IBM report telling us how much faster breaches are identified start to make sense. Now, the figures from the IBM report telling us how much faster breaches are identified start to make sense. There are products in the market that are already leveraging the power of AI and machine learning to enhance their analytical abilities, such as Microsoft Defense for Endpoint and Splunk. Our ability to predict has been cited as a key method for improving our overall security posture. It is at the heart of methodologies like DevSecOps. As discussed previously, AI models can be trained on data to make accurate predictions on training data and then eventually on raw unseen data. Now, if you think about automation as a sequence of if-then actions, for example, if code is pushed to demand, then trigger this pipeline, we can begin to see how AI can be harnessed to help us automate security workflows. Consider an example discussed in our previous task, a phishing attack. We discussed how, with AI, attackers can enhance this attack, making it harder for us to identify phishing emails from legitimate emails. Just as attackers can harness the power of AI and enhance their phishing emails, so too can we harness the power of AI in identifying phishing emails, as the AI model will be trained on countless examples of phishing emails, and so can recognize the patterns we may have missed. Once it has successfully predicted it is a phishing email, it can then make a prediction that this email should not reach users and automate the blocking of this email before it reaches them. Our ability to summarize or digest. In our industry, there are a lot of events, incidents, breaches, etc. And all of these generate artifacts. Artifacts that we have to read, understand, and digest to grasp the implications of what happens. These artifacts could be documents or incident reports, and reading them can take up a lot of time. Now, with the power of AI, we could have these tools summarize the contents of a document for us, so we get the clip notes of it. Now, being able to move on in minutes and have them summarize an incident that occurred, even drawing correlation between other incidents which we may not have picked up on. This, again, is a massive time save and gives us an enormous advantage in defensive context. Our ability to investigate. Another large part of security is troubleshooting and investigating, working at the root cause of a security issue or identifying what kind of attack we are suffering. The ability to query chatbots in natural language and have it respond like human-like fashion unlocks all kinds of help in this avenue. Suddenly, we can feed an LLM logs and ask it to identify what's going on, and the LLM can provide queries to be run, which give output helpful in diagnosis of the issue, helping with incident triage. These chatbots are able and helpful in any task involving human imagination. After all, it does have limitations. For example, threat hunting. It allows us to imagine possible scenarios in which attackers could breach our system. AI could think of potential avenues attackers would take that we wouldn't have thought of. Secure AI. So we have talked about adopting AI into our defensive strategies, but just like many other products, we have to adopt that in a more secure way. And these are a few things to take into consideration. Securing AI models. Many of the vulnerabilities mentioned in the previous task involve an attacker getting access to sensitive data the model has access to. The key to preventing these kinds of attacks is to secure the models themselves. One method of preventing unauthorized access is by enforcing strict controls over who can interact with them. This will involve implementing strong authentication measures and carefully defining access permission. The use of role-based access control and MFA, multi-factor authentication, can help restrict access and add an extra layer of security systems. As discussed, the training data a model is trained on can sometimes contain confidential or sensitive information, such as a patient's records. For this reason, Training data should be treated as other sensitive data and encrypted. Implementations of AI security standards. To ensure that the security of an AI system, you must implement a well-established standard frameworks. Incorporating these recognized security standards throughout the deployment and maintenance stages means organizations can proactively address potential risks. For example, standards like ISO, IEC 27090 provide guidance on identifying and mitigating security threats to specific AI systems. Following these best practices ensures you are adopting AI in a secure way, minimizing exposure to cyber threats. Model monitoring. In addition to spotting when a model's performance drops and flagging when it needs to be retrained, monitoring should also detect unexpected behavior, biases, or anomalies that may indicate a security attack. This can be done using explainability tools, examples of which include Shape and LAM. Alright, so let's answer the question. According to IBM, how many days faster does AI help identify and contain breaches? 108. What cybersecurity task benefits from AI helping to imagine attacker behavior we might not consider? Threat hunting. Explainability tools such as Shape and LAM help with what? Model monitoring. Alright, so we have talked about the theories. Let's go into the practical part of this room. There will be several cybersecurity scenarios where we can use AI to help us complete a task. So let's take a look at them. First is the log analysis. Logs are the first line of defense in cybersecurity, but interpreting them quickly is critical, especially when responding to an active instance. Let's see how I can assist by analyzing and explaining the log entry of these high-intensity situations to help or explain in general. So we can try this, copy and paste right here. So with this given log, AI explained to us that this log entry indicates that on April 22nd at 11:45 p.m. or a.m., I don't know, an SSH daemon running on Ubuntu system recorded a failed login attempt. Someone attempted to log in SSH by the user admin, which does not exist or invalid on this system. The login attempt was originated from the attacker IP address. The connection was made from the source port. Protocol was SSH. Login failed because the provided password was incorrect or the authentication was unsuccessful. This could be a legitimate user mistyping the password or an attacker trying to guess the credentials. The key security concern is that multiple such failed attempts might indicate a proof of attack or unauthorized scanning. So based on this log, we can't really tell anything, but the AI gives us several possible scenarios. Phishing email detection. AI can help defenders identify phishing attempts by analyzing suspicious emails from common red flags. So let's test its ability to catch a potential threat using a prompt like this. Here's a suspicious email. Can you identify if it's a phishing attempt and explain why? This email exhibits several red flags typical of a phishing attempt. First is a suspicious domain, which is Microsoft 365 support verify.com login. This is not an official Microsoft domain, which is right here. Alright, that's one red flag. Urgent and threatening language. The email emphasizes immediate action within the next 12 hours and warns of account locking, which is a common tactic to include panic and prompt quick, unthinking responses. We've detected unusual activity to restore access, verify your identity right here. We also have incorrect domains right here. Sender email address. The sender email address, security at Microsoft 365, is not an official Microsoft email address. Official Microsoft support email usually come with an address ending at Microsoft.com. Obviously, this is not Microsoft official email address domain, so that's a red flag. Generic greetings and request to verify identity via a link. So it goes through the whole email, spots some red flags, and explain to us why it's a phishing email. Of course, with our knowledge, we can easily say this is a phishing scam. Threat hunting scenario. Threat hunting relies heavily on creativity. Defenders must think like attackers to find hidden threats. As previously mentioned, the limit of human imagination can sometimes lead us to missing potential attack scenario. So let's see how I can help us brainstorm new hunting ideas using a prompt like this. Suggest 3 realistic threat hunting scenarios that a cybersecurity analyst should investigate within a corporate network environment. These are the 3 realistic scenarios for the threat hunters: unusual account activity or previous escalations, lateral movement via the internal network traffic, and the persistence mechanisms in system and application logs. So these are going to be the guidance or the real scenarios where the SOC analyst should investigate. We can also use AI for the content generation, like writing a regex pattern that would match a failed SSL login attempt. This one is really helpful, especially for those who are not very familiar with regex or what it is. So now let's try to get a flag from the room. We can just simply paste this prompt right here, and then eventually we're going to get the values for each of the fields, and we just replace those numerical values into this one to get a flag. And we do it right here. Let's break down these values. DNS over HTTPS, default port is 443, so it's going to be 443. The scene for the timer is 60 seconds, so that's going to be 60. And the Windows ephemeral port range size is 16,384. So that's it for the room today. We learned about AI and its building blocks, how AI can be used by attackers and defenders. In our lab, we got a chance to work with an AI assistant that helps us in different cybersecurity. This will provide you an overview of AI landscape in cybersecurity. I hope you enjoyed this room, and remember, in order to protect yourself from AI, it's very important to know the basics of AI and its building blocks. If you have any questions or confusion, feel free to reach out to me. Thank you very much, and I'll see you next time. Bye.